Welcome to Computer Architecture lecture. Today we will discuss about different type of addressing modes and addressing types in microprocessor. Instructions are represented as numbers. Therefore, entire programs can be stored in memory to be read or written just like numbers. This simplified software and hardware of the computer system. Each instruction is encoded in binary. It's called as machine code. The instruction it has the operation code and operand values. The operation code it's also called as opcode. This field specifies the operation to be performed. An address field that designates a memory address or register. A mode field that specifies the way the operand or effective address is determined. There are 5 different types of addressing types. The first one is the 3 address instruction. Here 3 operand values are used in this instruction. Example is add A, B, C. The meaning is the content of register B is added with the content of register C. The resultant value it will be loaded into the accumulator register A. The second type is the 2 address instruction. Here 2 operand value we have used in this instruction. Example is add A, B. The content of accumulator is added with the register B and then resultant value it will be loaded into the accumulator register A. The third type is the 1 address instruction. Here only one operand value which we have used in this instruction. Example is store C. Here meaning of this instruction is it copies the content of accumulator to memory location C. Here the accumulator means cache memory register. This is one of the important semiconductor memory. It's used to hold the most recently used data. The next one is the 0 address instruction. This is very important instruction. Here no operand value which we have used in this instruction. Example is push A. All addresses are implicit in this instruction. It pushes the values of accumulator into stack. The next one is the addressing modes. The definition of addressing mode is all the microprocessor has addressing modes. It's very important one. The definition of addressing modes are different ways in which the operands are specified. That means addressing mode is the way of addressing a memory location in instruction. Microcontroller needs data or operands on which the operation to be performed. The method of specifying source of operand and output of result in the instruction is known as addressing mode. There are different types of addressing modes are available in instruction of microprocessor. The first type is the immediate addressing. Here we are using 8-bit or 16-bit constant value. This constant value stored within the instruction. Example is move 200, R0. 200 is the constant value. The second one is the register addressing modes. Here the name of the register is specified as operand values. Here register number is encoded within the instruction. So example is move R1, R2. The content of register R2 is moved into the content of register R1. The third type is the memory addressing mode. Here the operand value is the location of memory. Memory address is encoded within the instruction or it holds the address of the memory location. Example is move 1000, A. That means the accumulator content is moved into the address 1000. The fourth type is the PC addressing mode. Here the branch address is calculated by the sum of the program counter and constant value given in the instruction. The fifth type is the pseudo direct addressing. Here the jump address is used for moving from one set of instruction to another set Here the jump address is calculated by 26 bits of instruction is added with the upper bits of the program counter. This diagram illustrates the different type of addressing modes with example. The first immediate addressing, we are using the constant value. So in add instruction, we are using the 3 operand value. The first 2 operands are S0 and then third operand is a constant value. So the constant value 4 is added with the S0 and then resultant value is loaded into the S0. The second is the register addressing. Here all the operand values are registers. The third one is the base addressing. Here the address content is added with the register. So the effective address is created by the address of the instruction and the register content. The fourth one is the PC relative addressing. Here the program counted value is added with the address and then the effective address is created. This effective address is used to store the data in the memory. The fifth type of is a pseudo addressing. Here we are using the jump instruction. So the jump instruction, the address is calculated by the 16-bit address value given in the instruction plus program counter. This is the sum of the notation for the instruction in the microprocessor. The operand value, it may be represented by in different way. It may be a 8-bit register or 16-bit register, or it may be a 32 register. We are using the general purpose segment register, constant value. It may be a 8-bit value or 16-bit value. So the data, it may be a register or the memory content. So this is the different type of notation which we have used in this instruction set. This is a move instruction example. Here the syntax of the move instruction is move destination register, source register. The operand, it may be a destination or source register value or memory content, or it may be a constant value. The indexed addressing. Here we are using the indexed addressing to store the set of data values. Here the assembler, it converts the variable name into constant object value. So the assembler is always used for converting the assembly code into the mnemonic code. So the constant offset is added to register to form the effective address. In this example, it illustrates the first statement. Move instruction is used to hold the index value. The index value 0 is stored in ESI. The second instruction, move EAX, array of ESI. That means the content of array is stored in EAX. Finally, the array of 0 is added with array of 4 and array of 8. These three array content is added and then resultant value stored in the variable EAX. Thank you. I hope this lecture it will be helpful to you.